Bright Duty. Every student matters.
Hello children, welcome to the session. In this session children, we are going to discuss a few question and answers from the topics that we have covered so far. So children, the first question is, what is an electric switch? So children, an electric switch is simply an on-off device, right children? And it helps us to regulate the flow of current through an appliance. The flow of current through an appliance. So children, what is the basis of, or what is the principle of this electric switch? The principle of this electric switch is that it either breaks the circuit or it either makes the circuit. Okay children, either it breaks the circuit or it makes the circuit. When it makes the circuit, we say current is flowing through the circuit and switch is on. When it breaks the circuit, it means no current flows through it and we say that switch is off. Okay children, so let's move to the next question, which is, what are the symbols of cell, bulb and a switch? So children, for cell, the symbol is, we have two parallel lines. One is the longer one, other is the shorter one. The shorter one is slightly thicker. So the longer one represents the positive terminal of the cell, whereas the shorter and thicker one represents the negative terminal of the cell. Negative terminal of the cell. Then children, what is the symbol of a bulb? A bulb is represented by a filament like this, which is enclosed in a circle. Okay, so this represents a bulb. Then switch, how is a switch represented? So children, it is represented by two dots and a slanting line like this, and if it is slanting position, we say switch is off. And then children, if we are connecting these 2 points, we say switch is on. Okay children, so these are the symbols of switch in off and on position. Let's move to the next question. What do we mean when we say the switch is on? So children, when we say the switch is on, we all know the symbol for it is the two dots connected by a connecting wire, right? This is a connecting wire connecting two dots. It represents switch on position. So children, when we say the switch is on, it means the circuit through which the current is flowing, the circuit is closed. What does it mean? It means that current will be flowing through the circuit and the circuit is complete. Okay children, and therefore we say the switch is on. Okay children, because the current is flowing, the bulb will glow and it means that switch is on. Let's move to the next question. What do we mean when we say the switch is off? So children, what do we mean when we say the switch is off? How do we represent switch off? By the symbol, we represent the two dots with a slanting line. This represents the switch is off. And in this case children, the circuit is incomplete. The circuit is incomplete, or we say it is broken. The circuit is broken. Then children, in this case the current will not flow through the circuit and we say that switch is in off position. Okay children, so let's move to the next question. So children, we have a homemade torch. Was there a switch? So children, in this torch, can you see a switch somewhere? So children, although when we are touching this bulb to the positive terminal of the cell, the bulb is glowing. Whereas when we take it away from the positive terminal, the bulb is not glowing now. Right children? So this bringing closer this so this process, when we are bringing the bulb closer to the positive terminal, it is acting like switch is on because we are completing the circuit. Whereas in the other case, when we are taking it away from the positive terminal, what we are doing? We are switching it off by breaking the circuit. Okay children? By breaking the circuit. Okay children? So this is what we mean by a switch when we say we have a homemade torch like this. Okay children? So next question. Give an activity to make a simple switch. So children, how can we make a simple switch? Let us discuss. So children, what we are going to do is, we will take a thermocol sheet and on this thermocol sheet we will fix two drawing pins. We can take a wooden board also children. Okay, so we number this as drawing pin 1 and this is drawing pin 2 for the convenience. Now children, to this drawing pin 1, we connect a safety pin, one ring of the safety pin like this. It is connected, and we have to make sure that we are connecting it in such a way that this safety pin is free to rotate, okay. And also we have to place this other second safety pin, second drawing pin, such that the safety pin can easily reach this point, okay children. So now we are going to connect two connecting wires with points 1 and 2. So children, and if we connect this to a, say we connect this to a cell, positive and negative terminal, and then we connect it to a bulb, okay children. So in this position, when the circuit is not complete, you can see that circuit is not complete over here. We say this is in switch off position. Children, this is switch off. Why is it switch off children? Because we have not connected the other terminal of the safety pin to the drawing pin 2. That is, we have broken the circuit. Now children, we have the same circuit. Just what we are doing, we will connect the other ring of the safety pin to the second drawing pin in this way. And since safety pin is made up of metal, it is a good conductor, so it completes the circuit. It completes the circuit, and now we have switch on position. We have now switch on position. The circuit is complete, and in this case we will observe that bulb will glow. So children, this is the simplest way in which you can make a switch and check it through use of this electric circuit. Okay children, having a cell and a bulb, okay. So next question, what is the purpose of switch? So children, the purpose of switch is, it is an on-off device, right children? Switch is an on-off device. It is as simple as that you go to a room and your mother asks you to switch off the light. What you are going to do? You will just switch it off, right? You are going to switch it off, right children? And when you are switching it off, what you are doing? You are actually breaking the circuit. And when the circuit is not complete, the current will not flow and the light will be turned off, right children? Okay. So switch works on the principle of regulating the supply of current, okay. So let's move to the next question. Give a diagram to represent an electric circuit with a switch. So children, we have this diagram as we have discussed in the previous question. What we are going to show? We will show an electric cell connected using wires to the two drawing pins, and we have this safety pin and it is connected to a bulb. So this is an electric circuit connected with a switch. And what is this position? This is an off position. And when we are going to connect both the drawing pins with the two rings of the safety pin, then in that case it will be switch on position, okay children. So next question children, the purpose of switch is to complete the circuit, to break the circuit, both A and B or none of the above. So children, as we know that switch is an on-off device which regulates the flow of current through a circuit by either making the circuit or breaking the circuit, right? So the answer will be C part, that is both A and B. When it is because first part says to complete the circuit. When the circuit is complete, the switch is in on position. And when we have to break the circuit means when the circuit is open and there will be no current flow, and in this case we will call it in switch off position, okay children. First question is, what is an electric circuit? So children, electric circuit represents a complete path or the loop through which the current flows, and it starts from the battery, one terminal of the battery, to the other terminal of the battery, okay children, other terminal of battery. And this whole loop is known as an electric circuit. We are going to understand this with the help of a diagram children. So children, suppose we have a cell over here, cell or a battery. This is the positive terminal, this is negative, and we have connected this with the bulb, okay children. And now children, current flows from positive to the negative direction, and as we can see, the current will start flowing from here. It will pass through the bulb, then again through this wire, and it will finally reach the negative terminal of the cell. And so we have a complete path for the electric current to flow, and therefore we call it as an electric circuit. Clear, children? So let us move to the next question, which is, what are the basic components of electric circuit? So children, in an electric circuit, what are the basic components? So the basic components are, first thing is connecting wires. We require wires, right children? Then we will be needing a cell or a battery. Also children, we will be needing a bulb, and finally switch. So children, these are the 4 components of an electric circuit. Okay. Let's move to the next question, which is, what are conductors? So children, the substances which allows the electric current, to pass through them are called as conductors, and the best examples for conductors are silver and copper. Although most of the metals are good conductors of electricity, right children? And we have an example of a non-metal too, which is graphite, and it is a good conductor of electricity. Okay children? So let's move to the next question. What are insulators? Children, insulators are the substances which do not allow the electric current to pass through them, are called as insulators. For example, plastic, wood, distilled water, and so on. Okay children? These are the examples of insulators. Okay, so let's move ahead. So children, which materials can be conductors? So children, mostly the metals are good conductors of electricity. Metals which such as silver, then we have metals such as copper, iron. These are all the good conductors of electricity. Okay, and also children, we have some non-metals. Non-metal like graphite is known to be a good conductor of electricity. Okay. So let's move to the next question. Which materials can be insulators? So children, insulators which do not allow the electricity to pass through them can be rubber, it can be wood, plastic, or glass. These are the non-conductors of electricity, and that is why children, have you ever seen the screwdriver or the tester? They have the handle which is made up of these insulated materials, so that we do not get an electric shock. Okay children? So these are the materials which are known as insulators. Okay children? Okay children, so let us now move ahead to the next question. Give an activity to identify different substances as conductors or insulators. So children, we are going to create a tester circuit. What we are going to do is, we will take a cell, we will connect it to a bulb. Okay, and here we will connect this to a sample that we want to test, whether it is a conductor or whether it is an insulator. Okay children? And children, one by one we are going to test, and if the bulb starts to glow, then that material would be a conductor of electricity. Why? Because only a conductor will allow the current to pass through it and complete the circuit, which will lead to the bulb glowing. Okay, but children, if the material that we are testing is an insulator, that is, if it does not allows the current to pass through it, in that case the bulb will not glow, and we can mark it as an insulator. Okay children? So this is the activity that you are going to conduct in order to test whether a material is a conductor or is it an insulator. Okay children? So children, is your body a conductor or an insulator? So children, our bodies are made up of 70% water, and we know that water is a good conductor of electricity, and so is our bodies. Our bodies are also good conductors of electricity. Okay, so this will be the answer to this question. Okay children? So children, let's move to the next question. Why are copper wires covered with plastic coating? So children, copper wires are covered with plastic coating. Why? Because the plastic coating is an insulator material, whereas the copper wire are conductors. So children, if we leave these wires bare, that is if we do not cover it with the plastic coating, there is a risk of us getting an electric shock if we touch them. So that is why they are covered with the plastic coating or an insulation material, and we call it as the, what do we call it? We call it as the insulation of the wire. Okay children? So let us move to the next question. Why do we remove the plastic coating from the connecting wires before making the circuit? So children, before making the circuit, we have to remove these plastic coating from the edges of the wire. Why? Because children, we have to expose the inner metal copper wire so that we can complete the circuit and it can allow the current to pass through it. Okay children? That is why we have to remove the insulation from them. Let's move to the next question children. Why should an electrician use rubber gloves while repairing an electric switch at your home? Explain. So children, you might have seen an electrician using rubber gloves before repairing any electrical device, and he does this because children, the rubber gloves, the rubber material itself is an insulator, and it will prevent him from getting an electric shock while dealing with the electrical appliances. Okay children, and that is why he uses the rubber gloves. Okay. So children, next question is, the handles of the tools like screwdrivers, pliers used by electrician for repair work usually have plastic or rubber covers on them. Can you explain why? Yes children, I am sure that you will be able to answer this, because there is no need to cram in science. You just have to apply the basics. If you know the concept, you will be able to answer this. Now children, think about the plastic or rubber covers. You know that plastics and rubbers are what? These are insulator materials, and they will prevent the electrician to get electric shock while dealing with the electrical appliances, and that is why they have handles made up of plastic or rubber covers. Okay children? So children, next question is, wood is a conductor, insulator, both conductor and insulator A and B, or switch? And we know that children, wood do not allow the current to pass through it, and therefore it is an insulator. Okay children? So the next question is children, the plastic is used to make the handle of a tester. Why? Because plastic is an insulator, plastic is a conductor, plastic makes it durable, or all of the above. And we know the answer, which is A part. Plastic is an insulator and it does not allow the current to pass through it, and we make the handle of a tester with it so that we can protect ourselves from getting an electric shock while dealing or repairing the electrical appliances. Okay children? So the next question is, why do we remove the plastic coating from the connecting wires before making the circuit? To complete the circuit, because the plastic weakens the circuit, both A and B, or none of the above. So children, we have to remove the coating in order to complete the circuit, because when we will remove the insulation, only then we will be able to connect it to the other component of the electric circuit, right? And therefore, in order to complete the circuit, we have to remove the plastic coating and expose the inner metal wire to complete the circuit. Okay children? So these were the questions from the session children, and I really hope that you would have understood the questions really well. Thank you so much for your attention.